Today, we're diving into a huge breakthrough from Google research that's getting people really excited. So excited, in fact, that they're calling it a Pied Piper moment for AI, a clever solution to one of the biggest problems holding the entire industry back.
So, to really get why this is such a big deal, we have to start with a pretty basic question. With all the amazing stuff we're seeing AI do, where is it actually, hitting a wall? What's the big bottleneck?
Well, the answer is surprisingly simple. It's memory. Plain and simple. The amount of memory these giant AI models need is just skyrocketing, way faster than the hardware industry can keep up. And this memory crunch is slowing everything down. Okay, so for our first section, let's go meet the main culprit. We're going to find the specific thing that's eating up all this memory, the real memory hog.
And here it is. It's called the KV cache. Now, the easiest way to think about this is like the AI's short-term memory. When it's reading a really long document or having a long chat with you, it stores important bits of info in this cache. That way, it doesn't have to start from scratch for every single new word. But here's the problem. The longer the conversation, the bigger this cache gets, until it just balloons out of control. It can even end up taking more memory than the AI model itself.
All right, before we go any further, let's just get 3 key terms down so we're all on the same page. First, vectors. These are just the numbers, the math that AI uses to understand things. Second, the KV cache, which we just met. That's the AI's cluttered short-term memory. And third, rope. Rope is a really clever trick that helps the AI know what order words are in, and it does that by kind of rotating the data for each word based on its position. Just keep those 3 in the back of your mind.
So, because of this massive memory problem, researchers found themselves stuck with a totally impossible choice, a classic catch-22 for how to solve it.
Now, the obvious solution seems to be something called quantization. It's just a fancy word for making the numbers smaller and less precise, kind of like squishing a huge photo down into a smaller JPEG. You save a ton of memory, which is great, but there's always a catch, right? And that catch, it's these things called outliers. Think of them as these sudden, extreme spikes in the data. They look weird, but they are absolutely crucial for the AI's accuracy. And if you just try to compress everything down, you flatten out these important spikes, and boom, the model just doesn't work as well. These outliers are basically the villain of our story. This led researchers to a real dilemma, a rock and a hard place. Option 1, you could compress or quantize the data before you do that ropey rotation thing we talked about. The good news is the outliers are easier to deal with. The bad news? You have to decompress the data every single time you use it, which is super slow. Okay, so option 2, quantize after the rote rotation. That avoids the slow decompression, but now the rotation has made the outliers all chaotic and random, which means you need other complicated, slow workarounds. Either way, you lose. It was a no-win situation. But then, you know how it goes with big breakthroughs. The solution wasn't a more complicated formula, it was just seeing the problem in a completely new light.
And that's exactly what the researchers said in their paper. They found a new perspective that just completely solved the dilemma. And this is where things get really, really clever. The big insight was actually incredibly simple. That rope process, the thing that helps the AI understand word order, it never touches just one number at a time. It always rotates numbers together, in pairs. And that one little fact leads to this incredible aha moment. See, if you just look at the outliers as a long list of numbers, one by one, they look like total chaos. It's just a random, spiky mess. But if you start looking at them the way rope does, in 2D pairs, and plot them on a graph, all of a sudden, a beautiful, perfect, circular pattern emerges from all that noise. The chaos was actually hiding a very simple order.
So what's the easiest way to describe points on a circle? Not with X and Y coordinates, because those are the spiky, messy numbers we're trying to get away from. You use polar coordinates. You just need 2 simple values, the distance from the center, the radius, and the angle. And here's the genius part. Both the radius and the angle turned out to be really smooth, predictable values that are incredibly easy to compress without losing any of that important outlier information.
And that's it. That simple, brilliant shift in perspective, from looking at a messy line of numbers to a clean 2D circle, that is the entire foundation for Google's new algorithm. And they call it, fittingly, PolarQuant. All right, so that's the clever geometric trick. But what's the payoff? What does PolarQuant actually get us in the real world? Let's take a look.
First up, a huge reduction in that working memory. PolarQuant slashes the size of that bloated KV cache by a minimum of 6 times. I mean, that's not just a small improvement, that's a total game changer. But it's not just smaller, it's also faster. A lot faster. In some situations, using this method can make the AI generate its response up to 8 times quicker. And now, for the most important part, the real magic. They got all of this, the smaller size, the faster speed, with, and this is a quote, zero accuracy loss. The model is just as smart as it was before. They didn't have to sacrifice anything. So how did they make it so much faster? Well, they used another brilliant shortcut. Because those polar coordinates are so predictable, the researchers could figure out all the possible math results ahead of time and store them in a tiny little cheat sheet, a lookup table. So now, instead of doing slow, heavy math on the fly, the AI just looks up the answer instantly. It's like having the answer key to the test. Now, having a brilliant idea like this is one thing, but making it actually run super fast on a real GPU, that's another challenge. To do that, they used a special programming language from OpenAI called Triton. Think of it as the bridge that lets you take a genius idea from a research paper and turn it into a practical, high-performance tool that actually works. And that brings us right back to where we started. This whole thing was so effective, so elegant, that people online immediately started comparing it to Pied Piper from the TV show Silicon Valley. You know, the company that cracked the code on compression. It's just shorthand for saying, wow, they actually did it. They found the Holy Grail. Because that's what this is. This is the dream scenario for compression. PolarQuant makes AI models smaller, it makes them way faster, and it makes them cheaper to run for everyone. And it does all of that without making them any dumber. It checks every single box. And that leaves us with one last really exciting question to think about. For so long, the sheer cost and size of these top-tier AI models has been a huge barrier. But if the biggest and best models can now run on smaller, cheaper, and more widely available hardware, what does that unlock? What brand new applications, things we haven't even thought of yet, are suddenly going to become possible tomorrow? That's what's so exciting.